All right, on to question 4. So we have a graph here that shows the volume of carbon dioxide released when 3 granular metal carbonates were heated. So we have here calcium carbonate, strontium carbonate, barium carbonate. So as they were heated, supposedly thermal decomposition happened and carbon dioxide was given off. Okay, which carbonate produced carbon dioxide at the fastest rate? So you want to observe the three graph, which graph have the steepest gradient, because gradient correspond to the rate of reaction. Okay, so obviously calcium carbonate here wins. It has the highest rate of reaction. How do the rate of the three metal carbonate relate to the position of these three metal in the periodic table? So you got to understand, the faster the rate of decomposition, right, the less stable the metal carbonate is. Okay, because you decompose faster, the metal carbonate itself is less stable. Okay, so the less stable the metal carbonate is, we can deduce that the metal is less reactive. Okay, so if it's less reactive, then it should be on a higher position in group 2. Okay, so the lower down you go in group 2, the more reactive it is. Okay, because the electrons are easier to remove. Okay, so from the graph, right, the rate of decomposition of calcium carbonate is the fastest, barium carbonate is the slowest. This is what you can get from the graph. So what this means is that calcium carbonate is the least stable, right? While barium carbonate is the most stable. So from that train of thought, right, you can deduce that calcium is the least reactive while barium is the most reactive. Okay, so what is the train of thought once again here? The rate of reaction. Okay, then you talk about the stability of carbonate. The stability of carbonate tells you how reactive is the metal. How reactive is the metal, which will tell you the position of the metal. Okay, so you got to have this rough train of thought running through your head. Very good students, when they actually look at the rate of reaction, right, they can almost instantaneously tell the position of the metal, okay, just from the rate itself, right? So let's go on to the next part. Strontium carbonate used in electronic application. Describe a test to confirm the presence of carbonate. The easiest test we want to use here is your dilute acid, mineral acid. So you can use HCl, HNO3, both are fine. When you add the acid to the carbonate, right, all carbonates, you will actually break down and you will release effervescence of CO2. Okay, so carbonate will break down to CO2 and gas evolve will give you a white PPT with your lime water, aka your calcium hydroxide. Okay, part 2, deduce the number of electron, protons, and neutron in one strontium ion. Okay, so the number of electrons, right, will be 2 lesser than the number of proton, because this is in group 2, right? Strontium is in group 2. Okay, so group 2, they will form strontium 2 plus, which means that the number of electrons will be 2 lesser than the number of protons. Okay, so you just need to check up your periodic table to see what's the number of protons. You take 2 away from that, that will be your number of electron. Okay, then of course you use your nucleon number minus off the number of proton, presumably is 88 minus your 38, which will give you 50 neutrons. Okay, part 3, C3 says, describe how strontium carbonate can be prepared in the laboratory. So you can actually mix your strontium nitrate together with sodium carbonate together. So notice what you want, right, is strontium, the metal, and you also want carbonate. Okay, so carbonate there's only like a few carbonates that are soluble, which is your sodium, potassium, and ammonium. Okay, so we choose to use sodium here. These are soluble. Okay, so you mix these two aqueous solution together, you will get strontium carbonate, which is insoluble. As a residue, which you can then filter out. Okay, remember to filter it. Wash it with distilled water, get rid of the impurities, and then pat them dry between two pieces of filter paper. Right, so that's how you can do it. Okay, part D, describe the effect of each of the following on the rate of reaction, assuming all other conditions remains the same. Okay, when temperature is increased, right, usually what will happen? Temperature increase, how will it impact the rate of reaction? Usually at all times, when temperature goes up, the rate of reaction will increase because reactant particle gain kinetic energy. They move faster, leading to more effective collision. Alright, so the rate of reaction actually increases. Okay. Part 2, when powdered carbonate is used, instead of granular, right, you have powdered. It means that you have more surface area, right? Increase in available surface area. Surface area of contact. So when there's more surface area of contact, there is a more effective collision, which will also increase more effective collision. Okay, sorry. More effective collision, which will then increase the rate of reaction. Okay, these are pretty common. Hi parents and students, I'm Mr. Kwa, founder and principal tutor from Mr. Chemistry. I do these videos to help more students understand difficult chem concepts, and hopefully more needy students who are not able to afford tuition, they can benefit from these videos. Please help me click that like button and share it with your friends so that more students can benefit. Thank you and see you in the next video. Bye.